Let's begin our journey in chapter 4 here, looking at 4.1, which is about translations. Now, translations is about taking a point, or what we're going to also do later on is take lines or even polygons and move them around on a plane. So before we get, I guess let's get started here. Take a look at our vocabulary. Our first word that we have is vector, which is a quantity that has both direction and magnitude or size and is represented in the coordinate plane. So you may see a vector, as you can see right there. Instead of parentheses, we have the left and right caret, and inside of it is 5 comma 6. And I'll show you what that means coming up in a little bit. Let's go to our next term. You're going to hear me talk about the initial point. That is the starting point. That is where the point is beginning, and the terminal point is where it is going to end. So you're going to have 2 points. You're going to have the initial, which is the starting point, and the terminal point, which is the ending. Hopefully it makes sense. Initial is start, terminate, end. So as we move down right here, let's take a look at what we call a horizontal component and vertical component. So when I'm looking at this vector, think of it similar to that of x and y, where this number 5 is your horizontal component. The number 6 is your vertical component. Now, the 5 and 6 doesn't tell you where the point is. It's telling you how many units from the initial point it's going to be moved up 5 to the right 6 to where our terminal point will end up being. Okay, so when you look at this right here with the carets, that is what we call component form. So I'll go ahead and put it right here. That ends up being, this is, the format of this is component form. Just like if we were to see parentheses around it, well, we would say that that is an ordered pair. So just know that this right here in that format is component form. Let's move down to our next term, and we have transformation. A transformation is a function that moves or changes a figure in some way to produce a new figure called an image. Okay, so when I talk about something that's been moved, that something, where it ends up is what we call the image. Before something got moved is what we're going to call the pre-image. So if I have my initial point, or that will be, think of that as the pre-image, and then where the point terminates or ends up at, that would be the image. So right here, as we show you a few more terms, I have for image, that is the new figure. Pre-image is the original figure. And for a translation, it's when you move every point of a figure the same direction and distance. You just can't move one point in a polygon. You have to move all 4 of them, or whatever it might be, depending on your polygon. So in the diagram right here, I show you, we've got, let's just say they're squares. And I will go ahead and label this point right here point A. So I'll say that if this is the original, okay, and I'll put this as the image, or sorry, pre-image, okay, that is your original. Well, if I were to move it, let's say like up 5 units to the right 6 units, this is where point A will now be. I will label this point A. However, I want to go ahead and put an apostrophe right there to show this is A prime. And that's how I know the difference between the pre-image point and the image point. So This right here, this whole entire polygon would be my image, which is the new figure. So that's how we know the difference between the two. So if I were to have, since I have 4 points, I would make sense to put this as point A, B, C, D. And then, so if I were to translate it, then we have A prime, B prime, C prime, D prime. Everything would, all points would move the same amount in our component form. Rigid motion. That is a transformation that preserves length and angle measure, what we call isometry. Okay? When we, in these diagrams right here, or what I just saw in the figure right here, from the pre-image to the image, everything stayed the same. The length, the angles. So if they were both rectangles, or sorry, they were both squares, then the 90 degrees would stay the same. And that's what they mean by rigid motion. Transformation that preserves length and angle measures, isometry. As we move down to the very last term right here, we have composition of transformations. That's when we have two or more transformations combined into one. So in the image above right here, there's only one thing going on. We could say it moved up and then to the right. But then let's say I have another transformation and it went from here, and then let's say it moved down there. And that would be a composition of transformations. That one shows that there's two things happening. Well, we could have three things or however many in a question that they want to include in a question. All right, so let's take a look at this core concept, a vector. The diagram shows a vector, and you have your initial point and your terminal point. So a vector, think of it similar to that of array. We have our initial point right here. We'll say that this is point P. Okay, there's your initial. And what they're showing you over here is where that point will end up at after a transformation. So right here, if you look, we have our vertical component, 5, 3. Now 5 is horizontal, 3 is vertical. Well, if 5 is positive, we usually tend to know that that's going to the right 5 units. And then 3 being positive, that's going to be vertical, up 3. And then this is where Q will end up being, which happens to be our terminal point. We read this, now with vectors, it's important to know, how do I know we're dealing with a vector? Once again, you look at the component form. Okay, so that right there is the bottom line on how you know that we have ourselves a vector. Also, if you take a look, and it's hard to see right here, but this PQ, above it, you've got yourself a half arrow. Okay, so that half arrow right there will represent the fact that this is a vector. A full arrow on top will represent this being a ray. So we can't have that. It's got to be that half arrow right there. Let's move on. We mentioned about the translation. Okay, and then in the translation, all points will be moved the same amount, depending on whatever the translation happens to be. And remember, how do I know the difference between the initial point and the terminal point? This is P initial. Right here, I've got P prime. That's terminal. All right, so make sure you understand that when you label things, you've got P and P prime or whatever letter, and then the prime of that. All right, moving along. Let's take a look at our extra practice. So we want to name the vector and write its component. We have initial point right here is M, where there's no point there. I know that this happens to be my terminal point because of the arrow. So this right here we can simply say is vector Mn. Don't forget, half arrow on top. Well, and then it says now let's write its component form. Well, how does it go from point M to point N? Well, simply just count things out. So let's go ahead and start with where M is. And we'll go 1, 2, 3, 4, 4 units to the right. And then we went up 1, 2, 3, 4, 5, 6 units vertically. Okay. So I can go ahead in vector form, put 4, 6. Take a look at number 2. Look at figure out where the starting point is, or the initial point, and where it ends. The initial point is B. The terminal point is A. Always want to start with the first letter being the initial point. And then above, let's go ahead and draw that half arrow. And this represents our vertex, BA. Do not turn the arrow to the right or going to the left. Doesn't work out that way. Always come up with the initial point. Just start off with that first when you're writing things out, and then wherever it terminates. So this one, remember, we always want to go horizontally. I'm looking at going 1, 2, 3, 4. Let's try 1, 2, 3, 4, 5. It's going 5 units to the left, so that means it's going -5. And then it went 1 unit down, -1. Lastly, right here on number 3, we have, hopefully you'll say that this happens to be vertex KJ. Let's figure out its component form. 1, 2, 3, 4, 5. So we got -5, and then it's going up 1, 2, and 3. And there you go with vectors and writing its component form. Pretty easy. Let's go ahead and take a look at the next page. Alright, so it says we have vertices of triangle ABC are 1, 2 for A, B is 5, 1, C is 5, 4. And you're going to translate triangle ABC using the vector given, and then you want to graph things out. So we'll do, you may want different colors, or you're going to need right here maybe a graph paper so you could draw multiple graphs. So I'm going to go ahead and plot our points. We have point A right there. Point B is at 5, 1. C is at 5, 4. Oh, 5, 4 would be up there. Let's move some of this stuff around. So there's point C, and we've got our triangle. Okay. And so using the vector, the first one being 4, -4, 0, what you're going to do is take every single point, and you're going to start off by subtracting 4 to the x, and then adding 0 to the y. So right here with A, it starts off as 1, 2. While A prime, which is going to be the image where it's going to end up being, I'm going to take 1 and I'm going to subtract 4 to it. So 1 minus 4, that gets me -3. And then I'll go ahead and take 2 and then add 0, which is going to be 2. So there's A prime. Let's continue on B prime. So B right here is at 5, comma 1. I want to take 5 and subtract 4 from it. So I'll end up with 1, and 1 plus 0 is going to be 0. So there's B prime. And then finally, for C prime, I've got 5, 4 is the ordered pair. Subtract 4 from 5, I get 1. 4 plus 0 is going to be 4. And there's C prime. So if I were to go ahead and graph things, you'll see right here. Let's go -3, 2. Got A prime at 1, 0. I have B prime. Sorry, is that, well, it's at 1, 1. Right? Yeah. Let's change that up right here. Messed up right here at B. It should be not at 1, 0, but at 1, comma 1. There we have B prime. And then we have C prime at 1, and then 4. All the way up there, and there's C prime. And there we have our triangle. It moved and shifted to the left. It didn't move up or down because, according to vector, it's at 0. So that's not going to move it up or down. It's just everything is being moved to the left 4 units. Okay? So hopefully that's pretty straightforward and pretty easy. So we'll go ahead and leave that there. Oh, I guess I could do one more. Let's take a look at number 7. So let's take A prime, or start with point A. We have 1 plus 1 because we have positive 1 right here on number 7. So our answer right there will end up being 2. And then we got 2 minus 3, which is -1. So 2 comma -1 is A prime. B prime right there, I got 5 plus 1 to get me 4. I have 1 minus 3, end up with -2. So there's B prime. And then C prime right here is going to end up being 5 plus 1, which is 6. And then 4 minus 3, which is 1. And there you go. All right, next up, look at number 8. It says, write the rule for the translation of the quadrilateral PQRS to PQRS prime. So remember, all we need to do really is come up with our rule, and let's start with, well, one of the points. Makes sense. Let's start with P right here. Okay, so we have P, and then we have P prime. So let's figure out how many units does it take to go to the right. It takes 1, 2, 3, 4. So from here to here we have 4 units. And then we move up 1, 2, 3. So we can go ahead and write our rule, and it's quite simply, we have the caret, and I'm going to put 4 comma 3, and that is the rule for our translation. Just like that. All right, if we take a look at number 9, we'll start with P, going to P prime. Looks like we go down 1, 2, 3 units. So I could put -3, and then it went 1 unit to the right, comma 1. And actually, must be tired that time of the day. Flip things around, right? Remember, the first number should be left or right, so I should actually have had 1. Goes to the right 1, and then it goes down 3. So 1 comma -3 should be our answer right here. All right, and there is number 9. All right, let's take a look down right here as we get closer to the end. They tell us that the image in number 10 is One of the points is 4, 5. That's where point J happens to be. So what we're going to do is pretty much use the translation right here, just like what we had when we had things in the component form, right? Very similar, taking something that's in component form, and they have this equation. So what is the image of J? Well, if J prime right here, we'll go ahead and take 4, which is x. We'll plug that in for x. So 4 plus 6, right? So actually, let me go ahead and put like all the rules together. So we have x comma y, and then it's going to turn into, and then we got 4 plus 6, comma, and then we got 5 minus 3. Okay, so I want to make sure I show you all the steps, and this becomes 10, comma, 2. And there is, right here, ends up being J prime. All right, number 11. Very good question here. One that is easily missed because they're not paying attention. But what am I talking about? Take a look at this right here. It says, what is the image of R prime? Okay, what is the image of R prime? Pretty much what we're saying is we got to go backwards. We got to figure out, well, what is, because we got to figure out what is the pre-image here, essentially. In number 10, if you look, there's no apostrophe next to that J. So we just need to plug things in to find what J prime is. But this time, what we're saying is we figured out what R prime is. It's 0, negative 5. And so what we need to do what we need to do to solve the problem is actually go in reverse, right? We got to go in reverse or in the opposite to help us figure out what the pre-image happens to be. Actually, sorry. Let me take that back. I didn't read the question correctly. It says, what is the image? So they give us R prime. What we're actually going to find is R double prime. What I just spoke about before, that's the trick question that I want to make sure you guys knew. But let's solve number 11 first. So let's kind of like rewind. And what I'm going to go ahead, we'll take 0, we'll plug it into the equation, right? We have ourselves x plus 6, comma, y minus 3. And so 0 plus 6 is 6. And then we have negative 5 minus 3, which is negative 8. All right? And so that right there is R prime. Now my question to you is, when I got a little bit ahead of myself, is what is the pre-image? If they ask what is the pre-image of this? Now we kept on adding 6 and subtracting 3 to x and y to come up with the next point. But if I want to figure out the point before, then what you'd have to do is go opposite. It's like, well, what do you mean by that? Think about it. What's the opposite of adding 6? It's to subtract 6, and that would move it backwards, right? So if I want to figure out the pre-image here, what would you exactly have to do? You'd take x minus 6, and then you'd also have y, instead of subtracting 3, you would plus 3, right? And that would help us find the pre-image. So if my image was 0, or R prime was 0, negative 5, and I want to find the pre-image, I would plug 0 in here, and I take 0 or 0 minus 6, and I'll end up with negative 6. And then I have negative 5 plus 3, and that'll get me negative 2. And that would be the pre-image, which would just be point R. All right, and there you go. Lastly, number 12, let's put everything together. It says, in a video game, you move a spaceship up 1 unit to the left and 4 units up. So think about it. You go 1 unit to the left, and you go 4 units up. Then you move the spaceship 2 units to the left. So you want to rewrite the composition as a single transformation. So our transformations starts off, we'll put x comma y, and we have the arrow. So this is make sure when you're writing a composition, it should start off like this right here. So let's think about it. We're moving 1 unit to the left. So that hopefully tells us that it's going to be going to the negative direction. But, all right, so I guess we can go ahead and say 1 unit to the left, and so that'll be x minus 1. And then you go up 4 units, that'll be y plus 4. However, it says that there's one extra thing. You move the spaceship another 2 units to the left, and this part right here would be impacting the x minus 1. So instead of just subtracting 1, we subtract 2 more to it, and so this will be x minus 3, comma y plus 4. And there is our composition. And there is section 4.1.